Hello and welcome back to Mr. Haas's math help videos. Today we're looking at lesson 22, and this is finding the area of polygons. Remember, a polygon is any shape that can have any number of sides. You could have a triangle, a quadrilateral, which means four, a pentagon, which isn't always a regular pentagon. Remember, the word regular means that it's all the sides are equal or congruent. You could have hexagons, octagons, septagons. Okay, so let's get started. One of the easiest ones is finding the area of a rectangle, and our formula for this is, sometimes you've been taught length times width. Well, you can also consider it base times height. Okay. Same thing, just different words. So that's our basic formula, one or the other. It doesn't really matter. And because it's multiplication, it doesn't matter which order you put them in. A lot of times I have students ask me, which side's which? It really doesn't matter. Yeah, from a standpoint of looking at the images, you might say this one's the length, this one's the height, this one's the width. But when you're multiplying them together, it really doesn't matter the order that you're going to put them in. Other instances where we're working surface areas, it'll be more important. Okay, so if we have a rectangle, let's say 8 by 4. Well, that's really easy. 8 times 4 equals 32. And if there are no units like feet, inches, centimeters, whatever, we just put units, or U, and it's squared because we have two dimensions. You're multiplying the length times the width, base times the height. So that's why you have the square. It's units times units, centimeters times centimeters. Okay, well that's that one, real easy. Let's go to another shape, another quadrilateral. So a quadrilateral has four sides. Let's find the area of a parallelogram. Okay, well a parallelogram has two pairs of parallel lines. Okay, there's one set and here's the other set, the other pair. Okay, and you will have a line, kind of a dashed line a lot of times, and usually the right angle symbol will be in here as well. Okay, you'll get a length or base of 10, and a height, well, we could say that this would be our height 3. Sometimes they'll throw in distractors, like this 5. You've got to look at it this way. You've got to say, well, that 5 is not the height of the parallelogram. The 3 is. It's there to just kind of confuse you. And it may sound like that's a mean thing to do, but it is what it is. That's their job. Is you're supposed to know what to use, and their job is supposed to kind of make you sure that you know, not make it really easy. So again, formula, because it is a quadrilateral, you're using basically the same formula that we did for our rectangle. Length times width, or more appropriately, base times height. Okay, so base times height would be 10 times 3 equals 30. Okay, and again, this would be units squared. Good? All right, let's do one more. Good old rectangle. I'm sorry, rectangle. Did I say rectangle? Of course. This is a rectangle, but it's a very special type of rectangle. It is a rectangle that has all the sides equal. Well, we know what kind of rectangle this is. That's a square. It's also a quadrilateral. And so we know that not only is this side 4, but so is this one, and this one. And you'll have then base times height. Same formula for the other two quadrilaterals here. And that would be 4 times 4, and that's 16. Okay? Units squared. Okay. Now, let's try something a little different. They're going to throw a curve at you. This is too easy for you, right? So how about finding the area of shapes with pieces taken out of them? So, if we had a shape, good old rectangle here, a little wiggly there, right? And this is our center line. All right. And we have a triangle on the inside. All right, like so. And this is kind of the shaded area. Good. All right. So they give us the 10 up here. That's this distance from one corner to the other. And the height of the rectangle is 7. They tell us that this base is 6. In other words, from here to here, right? That distance is 6. All right. So first, we have to find the area of the rectangle. Well, that's base times height. Base times height. That's 10 times 7. Well, that's 70. All right, good. Now we have to take away the area of the triangle, right? Well, let's remember our formula. Because a triangle is nothing more than a rectangle with some of the pieces gone, we know that it is 1/2 of the base times the height, right? Basically, whenever you're making a triangle, you've cut it in half. And in this case, our height is 7. So we have 1/2 times 7 times, and our base is going to be, I did the height, sorry, first, and then the base is 6. Okay, well, I'm going to have to say, well, 1/2 of 6 is 3, and 3 times 7, well, that's 21. Okay, so then we have 70 minus the 21, and you'll be able to use a calculator, I believe, on this. So now we're down to 49, right? So 49 units squared. Good? Easy, right? Okay, well, let's move on. Let's take a look at a little more complicated one. So say that we have a situation where there's a company and they're giving an estimate for siding the front part of a house or putting up bricks on the front part of a house, right? That happens, okay? And we know that the height of the house is 20 feet, right? 20 feet. We also know that the height to this point, the gutter point, is 12 feet. Okay, 12 feet there. We know that this distance across the front of the house is 16 feet. Oh, this we would be able to do, well, wait a minute, there's still more. And we've got a door, because you got to be able to get into your house. And there's a nice window so that we can look out and see the world. Right? Okay, so there's our window. Our window is a square, and its dimensions are 4 by 4. The door is 4 by 6. Okay, these are all givens. Now, some of the things that you're going to have to use is first you've got to realize you have something called a compound shape here. Okay? Compound shapes are shapes that are made up of more than one shape. We have our basic shapes. This has a square, or a rectangle, I'm sorry, and a triangle. Okay? So, we know this distance across here is 16 because it's the same on the bottom as it is on the top. So for our triangle, the area of our triangle, we have 1/2 times the base of 16, right? Times, what's its height? Well, that's going to be a little tricky here. You see, the total height to the top of the building is 20, but the point up to the measurement up to the gutter is 12. So we're going to have to take the 20 minus that 12. That means that the height of our triangle is 8. Okay, great. So then to find our area up here, this area, we multiply 1/2 times 16, well, that's 8, times 8, that's going to equal 64. All right, so we have 64 units squared for the triangle. Now we have the lower part of the house, this 12 by 16 rectangle. Base times height, 12 times 16. Okay, let's see. 12 times 16, that's 192. 192, okay. 192 units. Okay, so let's add these two together. We have 192 plus the 64. Let's see, that's going to be 256. 256 units squared. But wait a minute, we don't have to put siding on our window and our door. Okay, well, the door is 4 times 6. That's 24. And that's our door. And our window is 4 by 4. And that's 16. If we add the 16 and the 24 together, that is 40. So we've got our 256 minus the 40 gives us 216 units squared. That's our answer. That's how much siding or bricks, whatever you're doing, would have to be here on the house. Okay, so that's a pretty complex compound question. All right, now, another one that's kind of interesting, you have to think a bit. So, let's say that we've got, I don't know, a flag. And that flag looks like this. It's a nice rectangle. You know, flags are usually rectangles. Not always, but usually. Okay, and this particular flag has a different color. It goes from that height to that. Okay? And we know that our flag, it's kind of a rectangle actually, is 10 by 10. Okay. Well, we know that then our area would be base times height, which is equal to 10 times 10. That equals 100, right? That's easy. Now, what if this this part here was 5? What if the height here came up to 5? Well, that means that we have a base of 10 and a height of 5, or a base of 5 and a height of 10. So we have 1/2 times the base times the height. So we have 1/2 times 10 times 5. Well, half of 10 is 5, and 5 times 5 is 25. Okay, cool. So that means that this part, the whole thing is 100, and the triangle part is 25. Well, what if I was to say, how much of that, that flag is the ratio? Well, how much of it is? Well, here you go. Let's try it this way. Our ratio is 25 over 100, right? The whole thing is 100. The triangle part is 25. We divide both top and bottom by 25. Divide by 25. Divide by 25. And we have 1/4. Okay. Interesting. 1/4. 1/4 of the flag is colored like that. Well, we see that the height of the triangle is 10, well, or base, right? What about if we were to change things around a little bit? What if we were to say instead that the base here was 5? So if that changed, well, I'm getting a little bit too crazy here. I apologize. Let's skip that. That's fine. That's enough for now. We'll work on that more later. Okay, so sometimes they'll want you to know what effect changing dimensions of a rectangle will have on the area. Okay, so here's our rectangle, right? And let's give it 6 times 4. All right. Well, base times height is 6 times 4, or 24, right? Cool. What if we doubled one of the dimensions? Let's go after the 4. What if we made it 6 times 8? Well, that's 48. If we doubled this one, if we doubled one of the dimensions, we get, look at that, double the area. How about if we go back to the original and double the 6? In other words, 12 times 4. Well, that also equals 48. So if we doubled this dimension, we end up getting double the area. Interesting. Okay, how about, because basically all you're doing is this times 2, right? And it doesn't matter the order you do it in. Now let's think about this. What if we doubled both dimensions? 6 times 4 times 2 times 2. Or you could just basically say 12 times 8. Same thing, right? Well, 6 times 4 is 24, times 2 is 48, times 2 is 96. If I multiply 12 times 8, well, that's 96. So the thing they want you to see here is that if you double both of these dimensions, you get 4 times as much. Well, yeah, because you multiplied it both dimensions by 2. Okay, so that's all for today. Thanks for listening, and I'll see you in class.